Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It will run for approximately 30 minutes with time for questions throughout. I will now turn it over to our speaker for introductions.
Hi. Hello, everyone. My name is Nithya Narasimhan, and I'm on the AI Advocacy team at Microsoft. And today, I'll be joined by my colleagues, Sharmila and Dan, as we talk about a topic that's very, very interesting to all of you, Model Context Protocol. But before we dive in, just a quick run of show. We usually start the show off with like a highlight segment where we cover the top news from the past week before we dive into the spotlight. So let me just give you a couple of links to look at. The first one is Model Monday/Discord. All the things we talk about, that's our community. So feel free to join us there after this event if you have questions. And we will also host an AMA there on Fridays. We'll talk about it later. And there is a GitHub discussions forum. We will have a card for this particular episode there where you can put your questions on. We're also trying something new. So feel free to grab these links. If you've missed an episode, we actually have a Microsoft Student Learn Ambassador writing recaps of each week's episodes that you can find on Tech Community and dev.to. But right now, I want to start off with our weekly highlight segment. So I think my colleague Sharmila will probably be here in just a bit. But she did record the 5 things that you need to know happened last week. So without further ado, let's roll tape and see what's new in Azure AI Foundry this week.
Thank you, Nithya, and everyone, welcome back to Model Monday's highlights. In this week's highlight, we are diving into new models, smarter security, and infrastructure updates that are shaping the future of Gen AI on Azure. So let's get into it. And as usual, on every update, there is a QR code which links to either the blog or the model card. So please take a screenshot of the QR code. So the first update is that Cohere models are now available on Managed Compute in Foundry. So what is Managed Compute? Managed Compute is where you can bring in your own Azure infrastructure and deploy and use that infrastructure quota for deploying these models on Azure. So this means you can deploy like very command-line enterprise-ready language models with just a few clicks, but it's still backed by Microsoft SLAs and Azure Enterprise Security Stack. So if you think of like you can achieve low latency, easy scalability, and you still have robust guardrails, so which is ideal for production grade RAG use cases. So now it's easier than ever to go from idea to inference on your own infrastructure, like Azure infrastructure, securely and reliably. Now, the next update is on prompt shields. So with AI apps going mainstream and security is becoming non-negotiable, and just a few weeks back, we rolled out prompt shields, a new runtime layer that helps detect and block prompt injection attacks. Now, combining that with Azure AI content safety, which is now featuring image and multimodal filtering, you've got a very comprehensive AI firewall. So whether it's jailbreak attempts or offensive outputs, you're protected end to end while still delivering fast, creative AI experiences. Now we are moving on to some model announcements. We are excited to say that OpenAI's O3 Pro model is now available in Azure AI Foundry. It delivers GPT-4 turbo level performance with faster throughput and lower cost, and it's optimized for enterprise that are scaling AI across orgs. So if you've been pushing your GPT-4 and hitting capacity ceilings or latency limits, O3 Pro gives you serious firepower with better economics and seamless Azure integration. Now, the next in the line of model launches is our Codex Mini. So any developer who's building CLI tools and fast feedback workflows, Codex Mini is for you. It's a small, scalable code generation model purpose-built for command line scenarios. Think shell scripts, quick command scaffolds, automation helpers, all with low latency and minimal footprint. And it's perfect for embedding into your local developer environments or using as a low-cost, high-speed alternative for repetitive coding tasks. Then last but not the least, the model context protocol, just MCP, just got a serious upgrade with models. And at built in May, we released support for model-based access control, better inference routing, and integration with model usage telemetry for MCPs, Azure AI Foundry MCPs. And this improves observability, governance, and performance for scaled AI deployments. So if you're running multimodal applications or supporting regulated workloads, the new MCP makes your infrastructure smarter and more secure. So that's a wrap for this week's Model Mondays. From frictionless Cohere deployments to turbocharged OpenAI models and next-gen security, Azure AI Foundry is evolving fast, and we are bringing all that information to you. So see you again next week with more highlights. And now I'll pass it on to Nitya to get into the next section of our episode. Thank you.
Hey, Sharmila. Hopefully you're here, but this is actually perfect, like the way you set it up for this week. So for what it's worth, a couple of things. We are talking MCP this week, but in that last slide, Sharmila pointed out this work on MCP servers. We will have the folks from that particular blog post coming to speak to us in a couple of episodes from now. Look for the research and innovation episode. But in the meantime, we are now on to our weekly spotlight section, where we will put a spotlight with a 15-minute deep dive into our topic. And I'm so excited to have Dan Delamarsky with us today. So hello, Dan.
Hello. I'm excited to be here. Thank you for having me.
Yes. So I want to first set you up. So if you haven't seen Dan, he's been at every MCP event in the past week. He's been super busy. He was at Build, then at MCP Dev Summit, then AI Engineers Conference. So Dan, two things. What is MCP and why should people care? And then what are you going to talk about today? And then we can go over to the deep dive.
Cool. Yeah. So I'll put it this way, like for all the excitement that exists around like LLMs, AI, we know that the bulk of the value actually is usually locked behind the scenes of different like APIs and different systems, right? Like your Dropboxes and your Box and SharePoint and Salesforce. And the question always comes to like, well, if I have my AI systems, how do I connect to all this data? So MCP is, or Model Context Protocol, is quite literally like if you reverse the name, that's exactly what it does. It's protocol to provide context to models. That's what it is. It's USB-C for LLMs, and it makes it very easy to connect all these different data sources to LLMs to make sure that they can actually reason on it and provide some kind of insights or extract the data and act on it. And today we're going to be talking about some of the authentication authorization, because guess what? To connect all those data sources, you kind of need to have some credentials. And those credentials are coming from a standard, and we have that standard. And just recently, by the way, the spec revved to a new iteration. I believe it's 2025-0618. That actually has the authorization specification baked in its current kind of the current format. It's great, and I'm excited to talk about it. And by the way, when you'll see the talk, you'll see me refer to it as kind of the draft spec. It's no longer draft. It's production starting next week. Last week.
And I think we're going to roll tape, but I'll just say one other thing. I believe VS Code's recent release was the first one to have the whole MCP spec.
Yes,
is that right?
Absolutely. Yep. VS Code is fully compliant with the MCP spec, which is super exciting.
Yeah, so we'll have all those links for you right after this, but now we should roll tape and get the 15-minute deep dive into MCP.
Hey folks, I'm Dan Delamarsky. I'm a principal product engineer at Microsoft and a member of the MCP steering committee. And today I'm going to be talking about building protected MCP servers, because as MCP is gaining traction and a lot of folks are starting to host servers remotely in the cloud or any other provider, they care about making sure that those servers are protected from unauthorized access. So that's what we're going to be talking about today. I'm going to switch to my slides here. And one of the things I want to call out is that what we're going to be talking today is really applicable to remote servers, because we know that anything that's hosted in the cloud is not necessarily designed to be open to the broad public. And that is especially critical if your server is running in a way that connects to other APIs that require user authorization. And a lot of servers are like that. If you're hosting some business productivity MCP server that needs to connect to Dropbox or Salesforce or any other service, chances are that those APIs require some kind of user context that is important to have. And you want to make sure that you're gating the MCP server before you give access to those downstream APIs. Now, this is important for remote servers. It's not as important for local servers because a local server or local MCP server is just a binary that runs on the box. So if you can use NPX, you might be using one of the Python servers. It doesn't really matter, but it's just a binary that has access to a bunch of other libraries and ways to acquire that user context directly on the machine without interacting with any kind of standard authorization protocol, if you will. Now, why is this important? Well, first of all, if you're interacting with downstream APIs, if your server is the one that acts as the proxy to those APIs, that means that that API needs some kind of user context to be able to return the right data. What that means in practice is that you need to authorize a given user or a given service account, if your server is acting on behalf of itself, against that API. And what that also means is that that user context needs to be acquired somehow in the first place. You're dealing with that cold boot problem of having that initial bootstrap process of getting the credentials, transforming them into, let's say, something like a token, and then passing it to that API. Now, the API also controls which users have access to it. Now, there is an important distinction here. We're not talking about just kind of a broad definition of user access, but more of the API can decide what level of access it can grant to what users or what roles and groups. And we're getting in kind of the world of policy definitions, but it's a bit of a, scope overreach here. But the idea is that the API itself can determine who has access to what level of, information that it exposes. The API also can act differently depending on the context of the users that are requesting information. So if you have somebody that is an admin and they request user context, they might get a lot of information, versus somebody that is just a contributor might get a very restricted set of information about the exact same user using the exact same API call. So this context is very, very important, and it's especially important as we start exposing these APIs to LLMs with the help of MCP servers. Now, I did call out something that for local MCP servers, this is not as applicable. So why is that? Well, first of all, local servers work on the box with the context of the user that can be provided directly to the application. For example, if I'm running this on a Windows machine, I might have a Microsoft account already connected to my Windows machine. So my local MCP server can use built-in APIs to just request that user context and authorize a given user to whatever API it needs to invoke later on downstream. I am not necessarily authorizing myself to use the MCP server. It's more of the server actually needs to access some downstream APIs and it gets the user context from me. Now, this also means that the authorization can be done in any way that is necessary. You don't need to use OAuth. You just need to use a library that knows how to talk to whatever downstream API the local server is talking to, which in practice means that it opens the door for literally any implementation. Because it's a local binary, that means you can code in any approach that you really want and any approach that the API downstream requires. There's, of course, special cases, like if you have an MCP server that runs locally that is shared on the same machine between multiple users, like in remote desktop scenarios. But that's a bit out of scope for this particular conversation. And that does require some work, but it's left right now as an implementation detail to those that manage and build MCP servers that run on the box, or the local MCP servers. So I want to talk about the two specifications here that we have. So you might have noticed that in the MCP protocol spec, there is a authorization spec that's been authored or released on March 26, 2025, this year. That authorization spec actually required customers or developers or implementers of MCP servers to go ahead and implement an authorization server. It's a component that is responsible for essentially minting tokens based on user context that is being kind of requested and received by the client, which is complicated. Not a lot of folks want to do that from scratch, and it requires a level of security expertise that not a lot of folks even want to have, and we'll talk about that shortly. That also means that in this implementation, that server, the MCP server acting also as the authorization server, would need to keep track of token issuance, validate those tokens, make sure that whatever it receives is correctly structured and formatted, for this to be properly implemented, you would kind of need to be an OAuth expert. And not everybody wants to be an OAuth expert. So we worked with a community of security experts. We worked with folks at Okta, AWS, Dscope, and many, many others to make sure that we implement a draft specification that does this clean separation between the MCP server, also known as the resource server, and the authorization server. What this means in practice is that you no longer need to implement this from scratch. So if you're somebody that has an MCP server that deals with, I don't know, let's say Salesforce data, you don't actually need to implement any of the custom authorization logic to mint Salesforce tokens on the server or to mint tokens that you can then map to some Salesforce tokens. Instead, if you're Salesforce and you're building an MCP server, you can just make sure that you're correctly advertising what authorization server you're using on the server, and then the client, the MCP client in this case, is the one that jumps through the hoops of acquiring a token, going through the process, and following standard OAuth procedures. Which, by the way, all of this is snapping to OAuth 2.1. So we're following the standards. There's nothing super custom here. It's literally the OAuth 2.1 protocol. What this also means is that the server itself is not going to be minting tokens. The authorization server downstream, the actual, usually provided by an identity provider like, say, Okta or Auth0 or Entra ID, is going to be the one minting the tokens, and then the server is only responsible for validating them. Also, this means that the client now is the one handling tokens directly, and the server has very little to do other than make sure that the tokens that it receives are correct. I mentioned something that is crucial here, and that is that most developers do not want to be security experts, and they really don't, because for a lot of them, the crux of the issue is I'm building an MCP server to solve a very particular customer problem. That's what I want to accomplish. I don't really care about the details of what's the structure of a JSON web token, how to generate the signature, how to check the expiration date. Like, a lot of these things are problems that were solved by existing libraries, by existing authorization servers, by existing identity providers that handle a lot of the policy conversations. All of this is a solved problem. So we wanted to make sure that developers have a path to using existing tooling, using existing conventions, and focus on solving the actual problem they care about, which is implementing the MCP server, instead of chasing little security details that they have to implement for the server to work properly. So this led us to build this new authorization spec that I mentioned about that defines exactly this. A lot of the components of this specification are, and by the way, it's available publicly on the Model Context Protocol website. You can go and check it out. It captures a lot of the requirements, and the gist of it is that the authorization server now is advertised in what's known as a protected resource metadata document that is attached to the server. What this means is that now developers just implement this metadata and can point to an existing authorization server and just use that as their gateway, in a way, to get tokens for use with their MCP server. So there is no need to implement anything from scratch. You're completely absolved of the responsibility if you are building a protected MCP server and you want to use an existing off-the-shelf identity provider. Now, the server also has a standard way to tell the client what authorization server it uses, which is the protected resource metadata document, which can be either a JSON blob or it can be a token. And it follows the standard OAuth 2.1 conventions, which means that if you're using any of the existing libraries that do this, you're off the hook. You don't need to build anything from scratch and by yourself. Again, developer ergonomics here are very, very important. The goal is to get you from zero to a protected MCP server as fast as possible without having to be bogged down by a lot of these details that you might not even care about. On the client side, the client now is going to be responsible for doing the token dance, the token exchange, and making sure that the authorization code that it receives is actually exchanged for a token, and then it passes a token to the server. The only responsibility that the server has in this context is to make sure that it looks at the token, ensures that the token was issued to the server, which, by the way, very, very important. You gotta make sure that you validate tokens that your server receives. It's not just about the server being the proxy, because that's a completely bad pattern to adopt. The server needs to validate tokens and make sure that it's issued for it. You should not be doing token pass-through. And what this means in practice is that developers have very little to actually implement. You can, again, use off-the-shelf solutions Just plug and play like a bunch of Lego bricks, and you're good to go. Your server is protected. And there's plenty of identity providers that you can actually use for your scenarios, right? Like there's Entra ID, there's Okta, AWS Cognito, plenty of them. And as long as you use one that supports standard OAuth 2.1 conventions, you're good. Now, there's going to be some nuances, of course, around things like dynamic client registration, which requires some level of implementation. And if different providers do not support it, you'll need to implement this directly on your server. But the bulk of the interaction is now encapsulated on this authorization server side, not the MCP server side, which is extremely, extremely helpful for developers that want to build secure servers that they want to deploy to the cloud. Now, let's think about this a little bit and see like how does this actually work in practice? How does this work if we take an example MCP server, an example MCP client, and an authorization server? For that, I have this bit of a, I want to call it like a flow chart, if you will. So we have an MCP client that its first step is requesting data from the MCP server. It just asks for some information. It can be information about existing tools or any other primitives that exist on the kind of the MCP side of the world. And then the server will respond back with a 401 unauthorized, because the client did not attach any authorization context, with an attached pointer to the PRM, the protected resource metadata document, which in this case, as I described, can be basically a JSON file that tells you what the contents, what the authorization server is. And then what the client can do with that pointer is go ahead and pull that JSON file, that the PRM document that it needs to proceed. With that PRM document, it's going to pick an authorization server. It's going to use the scopes that are declared there, and then it's going to complete the authorization flow, because it's going to follow the discovery protocol to make sure that it connects to the AS, the authorization server. It's going to understand what is a token endpoint, what is the authorized endpoint, what is the register endpoint, go through that flow. You know, if it needs to register a client, it's going to register a client, and then the auth server is going to return tokens directly to the MCP client. The server is not on the loop here. MCP client is going to be the one that's going to store, cache the tokens and then pass them to the server. It's going to request data again with a token attached, usually in the authorization header. And then the server is going to return the data back. Again, very easy, very streamlined. Like the process follows standard conventions. Like I have here this very overly trivialized step that says complete flow. But what that means is that it just basically is going to go through the OAuth authorization code flow with PKCE. PKCE. And it's just going to complete it, get the tokens, and be on its merry way. That's kind of it. The client is now responsible for making sure that it's using proper tokens. It's making sure that it's refreshing the tokens. And the server is absolved of a lot of responsibility that it previously was tasked with. Here's an example of what this PRM document looks like. And here you can very, very clearly see that it's fundamentally not super complex to parse. There's a definition of the resource, which is the MCP server in this context. There's a definition of the list of authorization servers that are supported. It can be one or many. And by the way, the client in this context is going to be the one responsible for picking which of them to choose. Bearer methods supported that defines what exactly are the kind of the authorization bearer, the bearer token methods that the authorization server is capable of using. And then the scopes that are exposed to a particular client that it can use to then request authorization with that MCP server, and a pointer to some documentation. And for any additional details, I highly recommend going to the actual RFC document that you'll see linked below in the description to see more like what other properties can be included, because this is not a complete example of a PRM document. There could be more information there, of course. This is just a sample to give you an idea of how it's structured and what the client would see to parse it. If you want to have more information about what we just talked about, I highly recommend you check out the existing specifications on the Model Context Protocol website. You have the current stable spec to 2025-03-26, and you have the specification that is in draft that I talked about before. Again, very helpful to compare them. The draft one is going to be live soon, hopefully after this talk, and that's going to be another revision of the protocol that's going to enable you to do the PRM document, all these niceties that we talked about. And then not only should you read the specs, but you also should check out the security best practices document that you see at at the bottom here because it outlines some of the recommended approaches that you can use to make sure that your MCP server is secure, that you're not exposing data when you shouldn't, and that you're properly controlling the token usage, which again, I said it several times in this talk, you should always validate your tokens because the worst thing you can possibly do is accept a token on your server and then not check it and assume that just because you have a token that everything is fine. It's really not. So this is it. Thank you so much for listening to me talk about authorization in MCP. If you have any questions, do reach out. My contact information is in the description for this video. I look forward to hearing comments and helping make the MCP ecosystem more secure. Thank you.
All right. Thanks so much, Dan. I think that has been one of the most packed talks I have seen. There was so many links for sharing on the chat. We usually have like a 5-second delay, so I'm going to encourage folks who are on the chat to please put your questions in. But before we go ahead, I wanted to ask you, is there a place that people can go and learn about? I know you have those 3 links, but is there a place they can go learn about security best practices for MCP?
Yeah, so the best place for that is literally going to the MCP website. So if you go to modelcontextprotocol.io, there's a whole section called security best practices. And that's actually something that we're working with both security experts in the industry as well as Anthropic to make sure that we're properly documenting the flow as to how to build MCP servers and clients that are inherently secure. So highly, highly recommend to go there and check it out.
Thank you. And I'll keep an eye on for questions. So if you're watching this chat, please do. I noticed someone basically... So you have one conversion at least. I think Joel had basically said, I was reading about this new MCP security spec over the weekend. I'm happy to remove all the bearer token code from my MCP servers. So yay. But in that context, I was going to ask, I remember you did a really good demo at the MCP Dev Summit. So is there a place people can go look at like a simple sample just to get a kind of like an applied understanding of how to use that?
Yeah, so there's we'll share the links afterwards. We are aggregating a whole bunch of them on GitHub. The MCP C# SDK, if you go to the GitHub repository for that, has a pull request right now that we're finalizing with the whole authorization spec. And once that is in, you'll actually have samples built in directly into the SDK. And that's going to be applicable, by the way, to other SDKs as well. So if you're using Python, TypeScript, Go, it's all it's gonna come with time as we get, again, last week the spec just formalized, so now we're getting it all lined up.
And if right now, because of like you said, the spec is just out last week. So what can people expect going forward in terms of the security aspect of it, but also the broader MCP roadmap, if you have any insights?
Yeah, of course. So I think that the main thing is that the clients and servers will now start adopting the patterns that we've documented in the specification. So we talked about VS Code being fully compliant with the spec, but VS Code is just one MCP client. Like we expect that, Cloud Code and a whole bunch of other MCP clients that are out there to start kind of snapping to this. So if you're building MCP servers, things should just work, like no matter where you plug it in, which is kind of the beauty of MCP, right? Like that's the whole point is I want to grab the server and just plug it in any of my existing infrastructure and things will just magically work. Like I don't need to do anything custom in terms of integrations.
So we had a question on the chat from someone said, how do I mitigate security risk in an MCP implementation? What best practices should I follow?
Yeah, so as I mentioned, the security best practices document, like it is the place to get started. I'd say like go there, check it out. The links are going to be available. It's literally on the MCP website. There's more things that we are working on integrating through a variety of different channels, of course. Some Microsoft, some more generic in the industry. That's going to be, again, documented in the next couple of weeks. But I'd say like the security best practices doc is the starting point.
And I think my slides are frozen, but hang on a second. I think we're almost at time, but I wanted to, there we go. Let me quickly just give you a couple of things. Next week, we're going to have someone from Microsoft Research talking about SLMs and reasoning. But I want you to be aware of the Foundry Friday AMA. So thank you so much, Dan. I know he had to drop for a meeting, but if you have questions, Dan will be coming to our Azure AI Foundry Discord on Friday. So grab that link and join us there. We'll have 30 minutes to kind of talk through all of this. All the links he talked about will be in the chat, but also in that post that you'll see for the forum that you see right there. So you can kind of follow up on this. And last but not least, I'll leave you with these 3 CTAs. So if you found this series useful, don't forget you can register for the entire upcoming series. We've got, I think this is the second of 12 episodes in season 2. So you can go to Model Monday /RSVP to pre-register for the next I think, 4 episodes. Join the Discord. We share a lot of information in there. There is a Model Mondays channel where I will share these slides and all the information Den put out. And most importantly, if you go to that forum link at the end, it lists all the AMAs every Friday on Azure AI Discord. This Friday, the focus will be on MCP. So I can't wait to see you all there. Thank you so much for joining us, and happy Mondays. We'll see you on Friday.